Hello friends, welcome back. So in this video, we will see the definition of joint distribution function and its properties. So we know the definition of the distribution function of a single random variable x. It is defined as the random variable x taking some values less than or equal to small x. So that is nothing but for single random variable fx of x is nothing but probability of x less than or equal to small x. So here in case of joint distribution function, if we have two random variable x and y, the same definition of single random variable is extended to joint random variable case. So it is nothing but probability of probability of the joint event, probability of the joint joint event x taking values less than or equal to small x and y taking values less than or equal to small y, which is a function of both x and y. So it is denoted by fxy of x comma y, so which is given by probability of x less than or equal to small x and y less than or equal to small y. So this is the expression for the joint distribution function. The properties of the distribution function will be extended for joint distribution function also. So here the first property is fxy. So if both the random variables are taking minus infinity, then it is simply 0. And also if one of the variable is also taking minus infinity, then also its value is 0. And next, if y is minus infinity, if minus infinity, then also it is 0. So the minimum value is 0. The second case, the maximum value, that is if both x and y are infinity, both x and y are infinity, then it is 1. Therefore the distribution function, joint distribution function values also ranges between 0 to 1, 0 to 1. So the next one is we can get marginal distribution function, marginal marginal distribution functions, that is function of x or y from joint distribution function by substituting one of the value as infinity. So for example, if we want the marginal distribution function of x, then we have to take all possible values of y, that is y is equal to infinity. If we substitute y is equal to infinity, then we will get marginal distribution function of x. Similarly, if we want marginal distribution function of y, then in the joint distribution function, we have to substitute x value infinity and y value as it is. So from this, we can get marginal distribution functions from joint distribution function. The last property is, so the joint distribution function, is also a non-decreasing function, like single distribution function non-decreasing. So the joint distribution function is also a non-decreasing function of both x and as well as y. So this is the definition of the joint distribution function. This is the definition of the joint distribution function, and these are the properties. I hope you are able to understand the definition and its property. Thank you for watching. Please subscribe to my channel, share with your friends. Thank you.